Time series analysis involves the analysis of data points collected over a period of time. Machine learning techniques can be used to analyze time series data in order to identify patterns, make predictions, and gain insights from it. There are a variety of machine learning techniques that can be applied to a time series data, including regression, classification, clustering, neural networks, and SVM. When working with time series data, it is important to ensure that the data is stationary. That is, the mean and the variance of the data do not change over the time. This can be achieved through techniques like differentiation and decomposing. Overall, machine learning can be a powerful tool for analyzing temporal data and gaining insights that can be informed decision making in a variety of domains. DARTS is a Python library that provides tools for working with temporal data, that is time series data. It includes a variety of models, including the tools for pre-processing and utilities for evaluating the model. It provides model classes, right from classic models like ARIMA to state-of-the-art deep learning models like RNN, FFT. Facebook Profit can be used in this DARTS library. It provides time series utilities like resampling, differencing, and decomposition, data preprocessing techniques like scaling and normalization, focused evaluation metrics like MAE, MSE, and MAPE, that is mean absolute error, mean square error, and mean absolute percentage error respectively. Machine learning based models can be trained on potential large data set containing multiple time series, and some of the models offer a rich support for probabilistic forecasting also. So these are the advantages for using a DARTS library for time series data. I am about to use DARTS library for time series analysis and forecasting in Python. I am using the inbuilt dataset called as air passenger dataset that comprises of two components, time component and number of passengers traveled in that particular month. So I am plotting the data. By visualizing the data, we can clearly spot an upward trend and seasonal component. Obviously, it is not stationary. We have to use some pre-processing in order to make it stationary, and then we have to apply it on the models. So as in machine learning model, I am splitting the data into two halves, training and validation. It can be easily splitted in using this library by means of specifying the number of percentage I want it for training and testing. It can also be done by means of specifying the month. So it can be clearly an advantage for by using this library. So as we can see, we have to remove trend and seasonal component in order to make it stationary. So this library is a function check seasonality that returns if the time series data is seasonal or not, and also it returns the number of time periods that has the seasonality component in it. I'm also removing the seasonality, and I'm also removing the upward trend, and I'm plotting the data. As we can clearly see, there is no seasonal components or trend component, and the mean is constant and the variance is constant over the time. So I'm using a statistical test called as the ADF test, that is augmented Dickey-Fuller test, for evaluating my stationary component. As we can clearly see that the p-value is less than 0.05, so obviously states that this model is stationary. I'm about to use two models. One is auto ARIMA model and second one is NVIDIA's model. Before that, I'm plotting the data. I'm plotting the ACF and PACF. ACF, the autocorrelation function, and partial autocorrelation function are important tools in time series analysis for understanding the properties of data and determining the appropriate models that can be used for forecasting. The ACF measures the correlation between the time series and its lagged value. It helps to identify the presence of any repeating patterns or cycles in the data. A strong positive correlation or a specific lag indicates that the data is highly correlated with the past values at the lag. And I'm also plotting the PACF value. PACF, on the other hand, measures the correlation between the time series and its lagged value after removing the effect of intervening lags. So PACF can be helpful in determining MA model, and ACF can be used to useful in AR model. So first of all, I'm using auto ARIMA model. As I'm forecasting using auto ARIMA model, it cannot capture the trend. It can slide. It is not up to the level for capturing the trend of the data. And for an advanced model, I'm going for NVIDIA's model, that is neural basis expansion analysis time series forecasting. It It is a fully convolutional neural network that is designed to model time series data in a way that it is both accurate and interpretable. This model consists of a series of fully connected layers, each of which applies a nonlinear transformation to the input data. Another important feature of n-beats is its interpretability. The model can be visualized as a series of trend and seasonal components, which makes it easy to use how the model is predicting the data. It, it takes two arguments: input chunk length, that is the length of the input sequence that to be fed to the model, and output chunk length, that determines the length of the forecast of the model. And I'm running it through the 100 epochs, and I'm fitting the model, and I'm plotting the data. As you can clearly see, this n-beats model captures the data well and forecasts it really well, as like of my previous data. So compared to my auto Arriva model, this performs very well up to the level and captures the pattern behind the data. So for exploiting the temporal data, using deep learning techniques can be tedious and time consuming. While by using this library, it can be done within seconds, and do not occupy any GPU or TPU for computing the data. We do not need to use PyTorch or TensorFlow for capturing the data. It can be easily done using this library. So time series data can, instead of going for scikit-learn, it can be easily plotted in means of this library. So DARTS is very handy and is appropriate for using time series data. So thank you for watching this video. Thank you.